Hi guys, so today we're going to look at some operations with functions. So a lot of the math that we're going to start here is not going to be very different from anything you've seen in Algebra 1, but some of the notation may look a little bit different, and that's probably the new focus for today. So the first thing that's on here, it says f plus g of x. So you may not have seen something like this before. All that means, if you look up here, is that it's taking the f of x function and adding the g of x function. So all I'm going to do is take 3x minus 2 and add x squared minus 5. Then from there I can just combine like terms and I have my combined function. Now we don't need to solve this or anything because all we're doing is just finding what happens when I add those two functions together. It's not actually equal to anything. All right, on B, same concept, but this time f minus g of x, that is subtracting. So I'm going to subtract those two functions. Now when it comes to subtraction, we need to be careful because there's a pretty common mistake that happens here. Whenever I subtract, I need to make sure that I subtract the entire quantity that follows. That negative is going to get distributed to every term. So this is going to be 3x minus 2 minus x squared, then plus 5. Then from there, I can combine my like terms, and I get my remaining function. All right, looking at multiplication, remember when we multiply, we have to multiply each term by the other term. So this one would be an example of FOILing, which you did in Algebra 1. So 3x times x squared, I would do negative 2 times x squared. I would do 3x times negative 5, and then negative 2 times 5. There aren't any like terms here to combine, so at this point I'm done. Then the last one's division, but you'll notice this time instead of x, I have the number 2. So all that means is everywhere that there's an x, I'm going to replace it with 2. So it would be 3 times 2 minus 2, and then the g of x would be 2 squared minus 5. So that gives me 4 over negative 1, which is negative 4. All right, on my next one, I'm going to look at a different operation. So f of x plus h. So the f of x function was 3x minus 2. So all this means is I'm going to take x plus h and I'm going to substitute x with x plus h. So this is going to become 3 times x plus h minus 2. So that becomes 3x plus 3h minus 2. So it's important to note here we're not just adding an h to that function. That is not the same thing. We're replacing the x with the x plus h. All right, then looking at f, same idea. F of x plus h, we already know that is 3x plus 3h minus 2. Then we are subtracting the entire f of x function. So we need to make sure that negative gets distributed to everything. So this becomes 3x plus 3h minus 2 minus 3x plus 2. And then I can see what cancels out, and all I have left is 3h. So that's my operations. So now we're going to look at a new operation. So the actual algebra behind this won't be bad, but again, this is a new process. So this is something called composition of functions. So if you look at example A, the way we would read that is f of g of x. That's how we read it, f of g of x, or sorry, f of g of 3, f of g of 3. So what we're going to do here to evaluate this is we're going to start with what's on the inside, g of 3. So g of 3 is something we already know how to do. In the g of x function, we replace every x with 3. So g of 3 is the same thing as the square root of 3. Well, that replaces the g of 3. So what I still have is f of the square root of 3. That means in the f of x function, I replace x with the square root of 3, and I get the square root of 3 plus 4. All right, let's look at B. I'm going to start with the inside, f of negative 2. So replace x with negative 2. And then I'm going to evaluate the g of x function. I'm going to replace x with 2, which is the square root of 2. All right, so if you feel comfortable, go ahead, pause the video and try these next two. All right, on C, this is going to be f of the square root of 9, which is 3. F of 3 would be 3 plus 4, which is 7. F of negative 5 is negative 1. G of negative 1 is the square root of -1. And for now, we can just kind of leave it there. We're going to get more into this specific part once we get into quadratics. But for now, you can just leave it, or you can just say that there's no real answer to this. All right, now let's look at the next one, f of g of x. So g of x, we can't really evaluate that, but we know what g of x is. It's the square root of x. So I'm going to replace that with the square root of x. So now, in the f of x function, every x is going to get replaced with the square root of x. So this becomes the square root of x plus 4. Very similar to the next one, but f of x is on the inside. So f of x is x plus 4. So I'm doing g of x plus 4. So in the g of x function, I replace x with x plus 4. Now it's important to notice that these are not the same function. This one has the plus 4 on the outside and the plus 4 on the inside. It's not the same thing. What we also need to make sure of is we cannot take that square root out. All right, that's going to be a different value then. We can only simplify those square roots when there's multiplication and division. Now with composition, the notation we just saw, that's the notation we're going to see most often, but there is another notation that you can use. So if you see that open circle, it's not a filled in circle like multiply. That open circle there means composition. So if you see that open circle, you can just basically replace that with parentheses and treat it like composition. All right, so next example, very similar, just different functions. So go ahead, pause the video and try these ones. All right, on A, g of -5 would be -2. F of -2 would be 4 minus 4, which is 0. On B, f of 6, 6 squared minus 4 is 32. G of 32 would be 32 plus 3, which is 35. F of g of x, that's going to be f of x plus 3. So f of x plus 3 would be x plus 3 squared minus 4. Now be careful when you simplify this. X plus 3 squared is not just x squared plus 9. Whenever we do x plus 3 squared, we need to remember that we are multiplying x plus 3 times x plus 3. And if I were to FOIL that out, I would get plus 3x plus 3x plus 9. So it's actually x squared plus 6x plus 9. So be careful. Anytime you see a binomial squared like this, you cannot just distribute that negative. So this becomes x squared plus 6x plus 9 minus 4. And then I can combine like terms, x squared plus 6x plus 5. All right, let's go down to D, g of f of x. So that's g of x squared minus 4. X squared minus 4 replaces the x. So this becomes x squared minus 4 plus 3, which is x squared minus 1. This one we have the same letter, and that's okay. Just replace again, g of x is x plus 3. So I'm going to replace the x in the g of x function with x plus 3. So that becomes x plus 3 plus 3. So that is x plus 6. Then finally on f of x plus h minus f of x. So f of x plus h means we replace x with x plus h. So this would be x plus h squared minus 4. Then I'm going to subtract the entire f of x function. All right, let's go ahead and simplify this. X plus h times x plus h, if I FOIL it out, x squared plus 2xh plus h squared. Distribute that negative. And then from here, we'll see a couple things that cancel out. Plus 4 and minus 4, x squared and negative x squared, and I'm left with 2xh plus h squared. All right, the last two examples, nothing new, a little bit different way of looking at it. So we're going to look at a table this time. So starting with A, that is f plus g of 1. So f plus g of 1 means f of 1 plus g of 1. Well, f of 1, if I look at my table, when x is 1, f of 1 is 3. G of 1, if I look at my table, when x is 1, g is 4. So this is just 3 plus 4, which is 7. All right, let's skip down to E. So remember that open circle means composition. So I can rewrite this as f of g of 1. So starting with the inside, g of 1 is 4. So that replaces it. So now I'm doing f of 4. So f of 4 is 2. All right, so if you feel pretty comfortable, pause the video and try the rest of these. All right, f minus g of 3 means f of 3 minus g of 3. So that's going to be negative 6. F times g of 2, that's going to be 2 times negative 3, which is also negative 6. G of f of 3. So f of 3 is 0. G of 0 is 7. F of 1. So f of 1 is 3. F of 3 is 0. F of g of 4. G of 4 is 0. F of 0 is 5. All right, then my next one, g of 4. G of 4 is 0. And then I've got g of 0 is 7. All right, then the last one, very similar to this, but instead of a table, we're just going to look at a graph. So f of g of 0, so I start with g of 0. So on the g of x function, when x is 0, the y value is 2. So g of 0 is 2. Now I'm doing f of 2, so I go to the f of x function. When x is 2 on the graph, the y value is 9. All right, again, pause the video and try these next ones. All right, f of 0, so f of 0 is 1. G of 1, when x is 1 on the g of x function, my y value is negative 1. F of 0, again, is 1. F of 1 is 6. G of 4, so on the g of x function, when x is 4, the y value is 2. So f of 2 then, when x is 2, my y value is 9. Then f plus g of 3 means f of 3 plus g of 3. So let's find f of 3. That's 10. G of 3 is negative 1. So 10 plus negative 1 is 9. Then the last one, f times g of 2. So f of 2 is 9. G of 2 is negative 2. 9 times negative 2 gives me negative 18. So that's it for compositions. We're actually going to look at compositions again next class when we go over inverses.